This video is on the objective determine the degrees of freedom for a two-mean hypothesis test for population variances assumed unequal. Remember, when from previous videos, when population variances or population standard deviations are assumed unequal, this is a non-pooled situation, non-pooled scenario. We're going to be doing having a non-pooled estimate of the standard deviation. And I did go over this stuff earlier in an earlier video on an earlier objective. Hopefully you've been watching them, where I wrote this out previously. When you're conducting a two-mean hypothesis test where the two populations have unknown standard deviations, right? That just means you're going to be working with a student's t-distribution eventually instead of the normal. And if we assume population standard deviations or population variances are unequal, this is that non-pooled scenario. And again, in a previous video, I went over all what's happening. You're taking samples from different populations and you get sample means, two sample standard deviations, different degrees of freedom. But then you're eventually looking at the difference in these sample means, right? x1 bar minus x2 bar. And in this non-pooled scenario, the distribution of x1 bar minus x2 bar is going to be a student's t-distribution. And your calculator does some fancy calculation, crazy calculation for the number of degrees of freedom. But we're going to be more conservative here, and they're being more conservative in this Newton-Alta homework, Newton-Alta book. The number of degrees of freedom for the difference of sample means distribution is going to be the smaller, or the minimum, of n1 minus 1 and n2 minus 1. Right, so the smaller of the sample size 1 minus 1, sample size 2 minus 1. Whichever one of those numbers is smaller is going to be the number of degrees of freedom we're working with here for our t-distribution. And then we calculated the test statistic before, the t-score before. But this is all we have to remember here. All right, so for this problem, and again, if you want to read more about what they're saying, how they're doing things, click on More Instruction, look at their videos, their notes, their examples, and hopefully those help you. But let's just read through this one. In a large high school, 2 calculus classes were conducted at the same time. At the beginning of the year, the 52 students taking calculus were randomly assigned to one of the classes, with half in each. At the end of the course, all of the students took a standardized achievement exam. To determine if one of the calculus teachers was more effective than the other, the principal plans to conduct a two-mean hypothesis test to determine if there is a difference in population mean scores on the exam between the two classes. Assuming the population variances are unequal, right, and that's why it's a non-pooled test here, because you're assuming the population variances are unequal. How many degrees of freedom will the hypothesis test have? Now notice they mentioned the number 52, but they broke it up into 2 groups, right? Half in each group. There are 2 samples of 26 here. There are 2 samples of 26. So N1 would be 26 and N2 would be 26. So both of those, when you subtract 1, is 25, and the smaller of them would be 25. All right, they're both the same number. So in this case, when we end up looking at the difference between the sample means, the distribution of the difference of sample means, the number of degrees of freedom for our students' t-distribution is going to be 25. And that's all we're asked to figure out here. And they do the same and read through this answer explanation here. And again, I believe that that is really all we're asked to do. Yes. Okay. So again, real quick and easy one. Hopefully watching me do that or reading the more instruction, hopefully those help you out. This helps you out when you're working on this kind of a problem on your own and this homework on your own. And thank you very much for watching.